Hello and welcome to this IChemE Global Awards webinar. The IChemE Global Awards celebrate chemical, process and biochemical engineering excellence and are widely recognised as the world's most prestigious chemical engineering awards. Today we'll be announcing the winner of the IChemE Young Industrialist Award, sponsored by the chemical engineer. This award recognises the chemical engineer under 30 years old who best demonstrates their achievements and tangible application of chemical engineering skills to address important technical, economic, environmental or social issues. Here are finalists. We have Bashea Al-Dakan from Saudi Aramco, Heather Williams from WSP, Joshua A. Kelly from Biffa Waste Services, Kerin Graham from Atkins, Kyriakos Hadjidemetriou from the National Nuclear Laboratory, University of Manchester and Centre for Innovative Nuclear Decommissioning, Mohammed Faiz bin Omar from the Malaysian Refining Company and winner of the IChemE Malaysia Young Industrialist Award, Rhys Griffiths from PM Group, and Tao Ji Hao from Croda Singapore. All of our finalists have been invited to join us today to tell us more about their work and to answer your questions. Please enter your questions in the questions box on the GoToWebinar portal. So let's get started with our first presenter. It's Bashea Al-Dakan from Saudi Aramco. Okay, but Shea, it sounds like you may be having some technical difficulties. Is there anything you need some assistance with?
Yes, I couldn't find the share screen option here.
Okay, Charlotte in the background just help you with that.
Hello, Bashir. It should have come up as a pop-up message to ask to share your screen, but if you can't see that, if you go to the GoToWebinar panel, you should see a sharing box. If you expand that by clicking the arrow, you should have like a play button, and then there's a little drop down underneath where you can click which screen to share.
Oh, perfect. Yes.
Perfect. There you go. Excellent.
Okay, great. Okay. All right, good morning, everyone. It is such a great pleasure and an honor to be selected among the Young Industrialist finalists for this year. My name is Bashea Al-Dakan, and before I get started, I would like to first thank the Institution of Chemical Engineers and the Award Selection Committee for their kind invitation. What I would like to share with you today is a flavor of several different projects that I have worked on that tap into addressing certain industrial challenges, particularly in the oil and gas industry. But before I do so, allow me to give you a brief background about myself. So I am originally from Riyadh, Saudi Arabia. I have obtained my bachelor's degree in chemical engineering and economics from the Pennsylvania State University. After that, I joined Saudi Aramco to work as a petroleum engineer. During this time, I've done several rotations in Saudi Arabia's major oil fields as well. Currently, I am in this beautiful town of Ithaca pursuing my master's studies in material science engineering at Cornell University. So today, my presentation will cover three major areas. First, I will discuss the novel acidizing technology that we have developed at Saudi Aramco, which was also field deployed. After that, I will move on to a nanoscale development, exploring nanoparticles designed for the slow and controlled release of treatments, as well as for the targeted delivery with Professor Gianello's group at Cornell. After that, I will move on into discussing industrial outreach efforts that go beyond research and lab development.
And
So,
Bashir, sorry, I'm really sorry to interrupt, but it doesn't look like your presentation is moving on with your.
oh, sorry about
The
that.
slides aren't moving, that's all.
Let me see.
Perfect. There you go.
Okay. Great, wonderful.
Thank you.
No problem. So starting with the novel acidizing technology, which is the low viscosity retarded acid system designed for the stimulation of carbonate reservoirs. So what triggered the need for us to have a low viscosity fluid in these stimulation treatments? So carbonate reservoirs contain a large fraction of oil and gas resources worldwide. And the heterogeneous mineralogy of these specific reservoirs contain calcite, dolomite, or a combination of both. So acid stimulation have been widely proven to be very effective in dissolving the calcite and magnesium-based carbonates. Therefore, they provide highly conductive channels for oil and gas to probe. So several acid platforms have been explored in that regard with one conditional property. So they need to have strong retardation to allow the treatment to go deeper into the reservoir. And emulsified acid system have been the dominant class used for these specific treatments simply because they're very cheap to implement. So you can actually emulsify hydrochloric acid and diesel, achieving a temporary barrier for hydrocarbon adhesion to the rock surface. The problem with conventional emulsified acid system is that they have a very high apparent viscosity, so above 30 centipoise. So this results in a very high frictional pressure drop, low pumping efficiency, and the mixing conditions in the lab scale does not necessarily transfer at the field scale. So I have been in the field several occasions where these batch mixers are employed. So there are a lot of issues with quality control and phase separation that causes formation to the damage to the formations. So the idea here is that we can actually achieve retardation without the need for polymers or oil. And the way we can do that is by combining hydrochloric acid with soluble organic acids. So the mechanism works in a way to reduce the free water available in the system, decelerating the acid dissociation rate. So this treatment fluid has a low viscosity of 4 centipoise at room temperature with a high dissolving power and compatible with reservoir conditions. So on your right here, you can see computed tomography scan taken after a core flood experiment, where we flood a core sample with our desired treatment fluid. So the top image here, taken for a diluted hydrochloric acid system, you can clearly see phase dissolution occurring at the core inlet, meaning that a lot of the injected treatment does not make it or is spent at the core inlet, with branching occurring throughout the core. Whereas for the low viscosity acid picture that you can see at the bottom here, there is minimal phase dissolution occurring at the core inlet with one dominant wormhole. So this technology was successfully patented. We were able to get it approved for field implementation with promising results. Moving on to a different scope of work at the nanoscale, we're exploring nanoparticles for subsurface treatment release as well as targeted delivery. So starting with the first system, in many enhanced oil recovery applications, they rely heavily on surfactants assisted treatments in the mobilization of oil, simply because surfactants are very efficient in reducing the interfacial tension between oil and water, as well as altering the rock wettability to displace the residual oil out of the porous matrix. The problem with the neat surfactant-based treatments is that they're technically and economically challenging. So for example, premature adsorption is typically observed where a lot of the injected treatment does not make it far into the reservoir. Also, poor blockage that is caused by the additive chemicals to stabilize the treatment in harsh conditions. So they're very expensive to be implemented. The idea here is that we want to synthesize nanoparticles that are small enough to navigate through the porous medium. They are stimuli responsive with a hydrolyzable backbone, generating in situ surfactant as the hydrolysis continues. So this work is still ongoing, but our preliminary results show that we were able to successfully synthesize nanoparticles that are 50 to 100 nanometer in size, confirmed by the transmission electron microscopy images and dynamic light scattering. Also, when we did an accelerated hydrolysis test in a strong alkaline mixture, the hydrolysis is still controlled even at reservoir conditions. So also static contact angle measurements show the ability of our release surfactant to alter the rock wettability by driving the oil out of the oil matrix with only 25% surfactant release. So this was actually done on an originally oil wet calcite core. The other system that we're exploring is designing nano carriers for the subsurface targeted treatment delivery. So by doing so, we can actually have a more efficient and cost-effective delivery where the treatment can selectively target either the subsurface oil or the formation rock. This is done by only changing the surface chemistry of these nanoparticles. So for example, these are scanning electron microscopy images that you can see on the left here that show that these nanoparticles are less than 200 nanometer in size. And when we probe them with Nile-Rad just to visualize their interaction with oil-water emulsions using confocal microscopy images, you can clearly see from the micrographs taken in A, B, and C that the nanoparticles, which are represented in red here, assemble at the oil-water interface, whereas for our control sample, by only changing the surface chemistry, we don't see that kind of partitioning. So this has huge potential in delivering chemicals in a targeted fashion. Moving on to industrial outreach efforts, I have been very fortunate to be involved in many professional and social organizations. Currently, I'm acting as the corporate co-chair at Cornell's Graduate Society of Women Engineers, where I coordinate closely with industry representatives to secure funding, as well as arranging for essential networking opportunities for women in STEM. Prior to that, in Saudi Arabia, I have led the event planning and coordination team of technical programs at the Society of Petroleum Engineers Kingdom of Saudi Arabia section, which is the largest society outside of North America. So we basically organize for lectures and panel discussions, inviting speakers from the industry, academia, and the government, providing a platform for multidisciplinary discussions on the forecast of the petroleum industry. I'm also acting as the vice president currently for Saudi Students Club at Cornell University, where we also arrange for professional development, social, and outreach events. In concluding my presentation, I would like to thank again the Institution of Chemical Engineers. I would like to thank Saudi Aramco, particularly the EXPEC Advanced Research Center, for their tremendous support throughout my early career years up to my current master's studies. I would like to thank Cornell University and King Fahd University of Petroleum and Minerals for funding my research project. And with that, I come to an end of my presentation, and I'll be more than happy to take your questions.
Okay, thank you very much, Bashir, our first presenter today. So if you do have any questions, please enter them into the questions box on the GoToWebinar portal. While I give you a moment on that, let me remind you that this is one of a series of IChemE Global Award webinars taking place throughout November. If you'd like to find out more about what's still to come, and there's plenty more still to come, visit IChemE.org/global awards. That's IChemE.org/global awards. We don't appear to have any questions, so we'll move on. Thank you, Bashir. And our next finalist is from WSP, and it's Heather Williams.
Thank you very much. I think I just want to iterate what Bashir said, that it really is an honour to be part of these awards. And it's been a great opportunity to see what other engineers are up to and what we're all doing within this space. Brief background of me. So I did my undergraduate degree at the University of the West of Scotland, and then followed up with a master's at Imperial College.
Heather, sorry,
for me,
Heather, sorry to interrupt. We can see your next slides if you would like to put it into presenter mode.
So I need to change the screen.
Yeah.
How about that one?
There you go. That's perfect. Lovely. Thank you for that.
Perfect. Okay, so one of the things is one of the sort of highlights I remember from university was actually I went to my final exam with a bag packed, ready to start work the next day. So I really didn't miss any opportunities, and I do think that actually that's the way it should be, just to keep your career moving. Yeah, so I joined WSP as a graduate engineer after completing my master's, and have been privileged to go through a number of different projects with them, starting at very much the sort of validation side, learning about the technology, seeing up front what the individual items look like, understanding how they work, and really looking at the different sides of things and understanding actually the difference between an okay design and a really good design, which can mitigate all sorts of difficulties and challenges. So I did that as part of sort of the IPSON project, as well as the primary pharma manufacturing. Moving throughout my career, I then sort of started more looking at the design side. So with the Pyramel project, I was actually part of the design team, working alongside principal engineers in order to sort of work together a concept study, developing a batch model for the drug synthesis. That project actually, that project went on to detail design, and actually as part of that, once the detail design was finished, I then moved across and joined the Pyramel team on site during construction to look at the validation, to help with the team, and I actually became the on-site process engineer to help throughout the whole process. I then moved on to leading a few studies myself, so leading the concept design from a process point of view with AstraZeneca, and keeping going. I mean, I've led a number of different design studies, particularly looking at concept designs within the pharma industry, but I've also diversified, more so recently within some of the energy projects. So particularly at HyNet, looking at the CCUS project, which is happening in the Northwest. So this is the carbon capture, storage and utilization. I was primarily looking at the hydrogen network, modelling it across the Northwest of England, and having a look at the different stages of development and how we can use hydrogen in a productive way within the UK and its existing infrastructure. So I'm quite heavily involved with the IChemE. I always have been, from a student member all the way through. When I was at Imperial, I worked or helped with the Southeast Young Members Group. And from then I was actually invited to attend the 21st Century PI event with the other professional engineering institutions. And from that, we realised that actually the IChemE's young members were underrepresented in some ways. And from there, I then founded the National Young Member Committee for the IChemE, which is going strong. We've just had our AGM, and we're now on to our third chair, which is great. We keep growing and growing. I have included the email for the National Young Member Group. I will urge anybody as active young members to get in contact. We really are looking to develop it and keep it going. It's a great opportunity for young members to have their say, to develop the world of chemical engineering and really make it a future for us. One of the projects that I'm personally leading at the moment is around placements and the placement passport, looking at ways to make it easier for students to get placements, and sort of working with industries in order to sort of bridge that gap a bit better. I also do other things within the industry, within WRSP and outside of WRSP. I'll mention the top two. So actually, STEM Build Malawi was something that I was involved with this time last year, well, summer last year, where a team of, there were 24 of us. We didn't know each other prior to it. It was very much a collaboration team between WRSP and Jacobs. We were a team of all female engineers, and we came together in a virtual environment and designed 2 classrooms for a school in Malawi, and then got together and had 2 weeks to build it. And it was an incredible experience, well worth it. And I've made some friends for life as a result. It really was an amazing opportunity for me. And then the other thing is around gender balance. So I currently am the WRSP Water, Energy and Industry lead for gender balance. So I work with all the senior leadership within our business unit and across the UK in order to address the gender balance, looking at holding different STEM events to increase the pipeline, but also looking at roles that we can play within the industry to keep people in jobs, and generally make it a more enjoyable and inclusive place so that we can thrive and keep growing as an industry. So other achievements that I've had, so particularly across the last couple of years, I've been very fortunate to be listed as a finalist in the Female Mentor Awards for the European Women in Construction and Engineering. I had the NEPIC, which is the Northeast Region Young Member Achievement Awards within pharmaceuticals, and recently was one of the finalists in the the top 50 women in engineering in the sustainability. And that's everything from me.
Okay, thank you very much, Heather. So once again, then we have time for questions. So if anyone has any questions for Heather, please type them into the questions box on the GoToWebinar portal. While we wait for questions, if you've been suitably inspired to submit your own entry to next year's IChemE Global Awards, keep an eye on our website. We typically open for entries at the start of March each year. So that's icheme.org/global awards if you're interested in submitting an entry for next year. We don't have any questions come through, so we will move on. Thank you very much, Heather. It's now time for our third finalist, and from Biffa Waste Services, it's Joshua Kelly.
Joshua, sorry to interrupt, but I think you're muted. And we can see your we can see your webcam, but we can't see your slides yet.
I was there are no slides because the nature of my application, I was just saying it will be easier for me to convey this as a story rather than trying to put some slides up. So I didn't originally start out as a chemical engineer. Left university after studying chemistry and went to work in the waste management industry, having had the standard visions of being in white coats, etc. I found myself stood in the middle of a yard full of operators running a shift, managing waste from the oil and gas industry. And that was a little bit of a culture shock. And I think the thing that hit me most was that there were things I could see we could do better in terms of both the chemistries we were using to treat waste and the business processes. which had come out of some of the work that I'd done whilst I was at university over the summers in various industrial plants. And so I found myself pushing quite hard that we could do a lot better. And it turns out that if you push really hard that we can do better, you'll get challenged to prove it. And then if you prove it, people will start to take you seriously. So within about 12 months, I found myself running 3 tank farms on the northeast coast of Scotland, receiving materials from the offshore E&P industry for treatment as the technically competent manager, and found myself trying to optimize these different processes, and ended up picking up a copy of Coulson and Richardson because I needed that information. I'd been trained to work at a lab scale, and I was now working at the 500-ton scale. So kind of picked that up, ran with it, was able to deliver substantial cost savings over the 6 months that I was seconded up there. And I think we delivered some significant environmental benefit as well. We were sending a lot of material to really energy intensive processing that didn't need to be, and we were able to significantly reduce the energy use. So unfortunately, this was about 2014, the oil prices dipped and I found myself redundant. So I went to work for Biffa Waste Services, and again found myself pushing very hard that we could do better. And that same recognition process happened, and after about 6 months I was seconded to act as the R&D project manager for the hazardous waste division, which is where things started to get really interesting. I ended up leading a number of different projects around improved recycling of beverages and beverage cartons, then disposing of nerve gas, which had a very large safety element, would you believe it? And that was a very challenging project, working with some partners from the EU and across the EU. So then moving on from that, did the project procurement, initial design, tendering and project management for rebuilding a facility that we had in Scotland, probably about 2.5 million capex in the end, and quite a lot of civils as well, because the site was starting to move around on its strata. So that brought in another discipline. And it was during this period of time that Biffa clicked that I wasn't actually an engineer, and so not being abashed by this, decided that it would be best if I was to go and get formal training in engineering. So the University of Strathclyde, who delivered not only the best but at the time the only distance learning chemical engineering degree, kindly obliged, and I've done that over the past couple of years and came out with a distinction, which was gratifying. But if I could go back and do it again, I might not. It was certainly an experience working full time and doing that. And what I started to realize doing these projects was that this push that I had to do better, it was restrained partially by lack of imagination within the waste industry. I'm not going to claim that it's always been particularly imaginative, but it was also constrained by the financial conditions and issues around the cost of capital and the way that the projects were financed, investor trust, and the regulatory environment, the policy environment didn't really drive positive change. It just stopped backsliding. So, and I was a bit frustrated that we couldn't do the best that we knew we could do as a company because of these external factors, and I wanted to know why. And a simple answer, anyone could tell you that. So I wanted to know why these decisions around money were what they were. So I started getting involved in various professional organisations, initially with the Royal Society of Chemistry and the Chartered Institute of Waste Management, and ended up acting as their representative to the UN Environment Programme during the IChemE, which is the Strategic Approach to International Chemicals (brackets) and Waste (close brackets) Management treaty. And they have a Beyond 2020 programme that's now a Beyond 2021 programme, because we were meant to be at ICchemE in about 2 weeks' time in Bonn. And this was looking at how can we improve the management of chemicals to contribute to sustainability on a global level. I met a lot of interesting people there and had my eyes opened around how policy works, and certainly international policy, how it was important to structure things to suit different environments, and began to get a real grasp of how public policy shapes our economic structures, and how the economic structures shape the investment, which then drives the internal financial decisions within companies, which then drive our engineering decisions. To some extent, there are certain engineering decisions which have been made 10 years ago by a regulator that had no idea what they're on about. I might be being a little harsh to the regulators, and we don't necessarily see it in our day-to-day practice as engineers. But I was starting to see this picture, and I was very passionate that we could do better with sustainability, and I started to see a wider picture of sustainability as well. So kept getting involved. I'd been sat at that event with someone from CEFIC, who are the European, I can't pronounce it in French, but the European version of the Chemical Industries Association. I believe the CIA is a member of CEFIC. And they introduced me to some people from the Society of Chemical Industries in the UK, who were running a project for the UK Chemistry Council around sustainable consumer products manufacturing. So I had a chat with the person who was responsible for leading that, and they asked me to co-chair a group on life cycle analysis, not because I was a life cycle analysis specialist, but because this broad brush, big picture vision that I was able to articulate around how sustainability policy worked was important. And they needed someone who could provide that leadership and move a room without necessarily getting bogged down in the technical detail. So I've been running that program with my colleague within the SCI, Julia Creasy from Croda, and we're hoping to run our first kind of roundtable webinar probably next week, if all goes to plan, with 30 or 40 people from different sectors that support the consumer product supply chain. And that will hopefully bring forward the evidence contributions that we need to justify that portion of the sector deal in the conversations between the Chemistry Council and BEIS around securing £1.3 billion for the process industry in the UK, aimed at addressing sustainability challenges whilst also delivering economic growth. And I think that's what I've been passionate about. It's become obvious to me that we can deliver economic growth, we can deliver financial growth for our companies, do good engineering, and improve sustainability. They're all compatible, and I think there's an old-fashioned picture in some people's minds, especially within certain sectors, that you can't have all of them. And because it's efficiency-driven, the efficiency drives the financial and business benefits, and at the same time, that lower use of resources drives the sustainability benefits. So actually, sustainability is linked there. But articulating that to people, especially in a policy sphere, can be really, very hard, because you have to take very complex ideas, distill them down, put them across. So that kind of continued advocacy within a number of formats. I've been providing advice to DEFRA on their submissions to IChemE and some of the other UN Environment Programme activities, on the basis of, again, giving that big picture vision from industry. And I think this is the advantage I've had in working in the waste industry. I get to see everyone's dirty secrets. Everyone can show you the shiny new sustainable plant, but the one half a mile away that's falling down, that's where the gains are to be made. So that's the vision that has allowed me to articulate that in these formats. So it's that kind of jump from not really being an engineer to delivering large engineering projects as a client's engineer, through to getting involved with my professional bodies on top of what I do in work and providing advice to these policy groups, working this kind of industrial advocacy role with the Society of Chemical Industries, but also kind of evidence developing and policy development. That's kind of got me nominated here. And I think just to put the icing on the cake, some of the work that I did when I was doing that MSc with Strathclyde was looking at merging econometric modelling with process systems engineering. If you can create an economic model, you can create a model of your engineering system. Why can't you marry them up and look at different ways of running things to get the model that best fits the way the market will respond to putting that plant in action, rather than assuming how the plant will affect the market and building something that fits your assumptions about how the world works, when the world may not work how you think it does. So put that together. I was fortunate enough to be asked to present at the second international conference on sustainable production and consumption on that topic. That got cancelled, so I did present at the virtual webinar that IChemE held, and I owe the editor of Sustainable Production and Consumption a manuscript when I have time to write one, or finish writing one, should I say. I think that story and that desire to do better and that getting involved and really driving forwards, when I started, I didn't really know what I was getting myself into. I didn't really understand that someone like me could contribute to policy, let alone make major contributions. And so I think, I'm not sure, but I think that's why I'm here. And that's me. Any questions?
Okay, thank you, Joshua. So as Joshua said, we have a few moments for questions. So if anyone has any, please once again use the questions box on the GoToWebinar portal. We'll just give you a moment for that. And while we do, this seems an opportune moment to thank our volunteer judging panel, led by head judge Keith Batchelor. The judges, as I say, all volunteers, have worked tirelessly to review and score every entry. You can find out more about the judging panel on the IChemE Global Awards website. We don't appear to have any questions, Joshua, so thank you very much.
Thank you.
Let's move on. Our next speaker is from Atkins, and it's Kerrin Graham. So Kerrin, over to you.
Thank you very much, Matt. So I am Kerrin Graham. I'm a graduate process engineer, and I work in Atkins, so the engineering consultancy, which is as part of the SNC Lavalin group. I work in the oil and gas sector in Aberdeen, but previously I've lived in Edinburgh, and that's where I studied at Heriot-Watt University, where I got my master's in chemical engineering with oil and gas technology. So then after graduating, I moved to Aberdeen in 2018 to start the graduate programme at Atkins. And so I'm now just starting my third year of the graduate scheme. I thought I would just talk around a couple of the kind of key projects that I've been involved in so far in my career. The first of which is low pressure operations. So it was my work in this project that was kind of the key driver for my nomination. So the aim was to assist a client in extending the field life and maximising the production of a brownfield asset they had in the North Sea through reducing the arrival pressure of the production fluids on the platform, and then obviously reducing the back pressure on the wells to maximise production. The approach we took to this was to perform a topside capacity assessment using Atkins MassCap. So MassCap is a in-house capacity assessment tool which integrates with HYSYS. I was able to utilise this to efficiently assess the capacity of the topsides across the future production profile that was provided by the client, considering a broad range of reduced operating pressures for the topsides. The LPOps project started as a 15-week feasibility study, the success of which resulted in 4 back-to-back projects spanning 18 months in total. So the feasibility study, here we identified any constraints to production through a capacity model, and then we looked at ways in which we could debottleneck each of these constraints. The initial constraint we identified as we reduced the pressure was a constraint in the produced water system due to an inability to maintain a sufficient pressure drop ratio across the hydrocyclones. That was then followed by a constraint in the primary separation system with poor liquid-liquid separation performance and high inlet nozzle momentums. And the constraint after that would then be in the gas compression system due to insufficient head to meet the set discharge and export gas pressure. Overall, we combined debottlenecking options to unconstrain each of these bottlenecks and created 9 project options, which range from low to high capex. Following on from the feasibility study, we conducted a life of field assessment. So this was actually a step away from low pressure operations, and this was assisting the client in identifying what the best strategy would be for the asset over the future field life. So here we were looking at actually maintaining the operating conditions across the plant as per they are currently, but determining what capex is required to completely debottleneck the plant so that it has the capacity to process the maximum potential of the reservoir should a number of theoretical wells be added to the current well stock. At the end of this study, the client selected that the future for the asset should be to pursue with LP operations, and that then takes us into the minimum modification study. So the minimum modification study came about from the original feasibility study. Is when we were defining the project options, we actually realised that there was ullage in the topsides at present, and there was scope to actually optimise operating conditions already to engage in marginal LP operations and then benefit from increased oil production. So here I performed a technical assessment of the current operating envelope of the topside equipment and identified what the control changes were to the plant so that we could safely reduce the operating pressure of the topsides incrementally, and also the key processing parameters that we needed to monitor throughout this period to make sure that the plant was in fact staying safely within the operating envelope. I rounded this off into a temporary operating procedure that I wrote for the client, and this would then enable the asset to perform a low pressure trial so that they could identify the benefits of reducing the operating pressure and also to confirm the operating envelope was in fact what we'd predicted. I was lucky enough to be able to go offshore and walk through this temporary operating procedure with the platform OIM as well as the control room technicians, and I also offered engineering support throughout the trial as it was conducted as well. From a successful trial, the client then proceeded into a capital project for LP operations. So this was looking at installing new equipment in the produced water treatment to debottleneck that constraint, as well as realigning an oversized secondary separator to operate as a primary separator, and also restaging the gas compressors in the gas stream. This was quite a large scope, so at the start of it, it did require a 10-day 4-man offshore site survey, which I coordinated, being the most familiar with the project and also with the asset, having previously visited it. So on this survey was myself, piping engineer, structural engineer, and an EC&I engineer. So there is quite a lot I could talk about the project, of course, spanning over 18 months. However, I thought I'd kind of pick out just a couple of key results from my perspective. So the first result is with regards to the minimum modification study. So like I said, we were able to do a trial in line with my temporary operating procedure that I developed, and we showed that we could actually increase production today by 500 barrels with no requirement for capex and no physical modifications to the topsides. So that was a great benefit for the client, and also it proved the concept of low pressure operations as well as the actual capacity of the topsides, which did align with what we had predicted. This then instilled confidence in the client, like I said, to then go into a more capital project from which we conducted the pre-feed for. The solution we defined in the pre-feed would return an additional 6 million barrels over the remaining 15 years of the field life, and we estimated that it could be achieved with a capex of around 25 million. In terms of a more personal result, I gained invaluable technical experience being the main process engineer on the 4 projects, working very closely with the various disciplines, my colleagues, working closely with equipment vendors, the client, and also getting the opportunity to work offshore with the operators of the asset itself. So on to the next project then. So this is a more recent project that I've since completed following my submission. So this is a right sizing and process optimization study. Again, this is looking at a North Sea brownfield asset. And here we were looking to help the client in optimizing their process so that we could either reduce their CO2 emissions, reduce their operating expenditure, or find ways in which we could increase their uptime and therefore export revenue. Again, this was a topside capacity assessment using our MassCap tool, and it was a 10-week study. The first part of the capacity assessment was to identify any existing bottlenecks that would occur across the production profile, and also identify equipment that had low utilization or operating with high recycles, for example, compressors, or any key equipment or utilities that were operating with low efficiency. After identifying these pieces of equipment, that then formed the scope for then right sizing and optimizing. So we developed 32 various options, again from low to high capex, ways in which we can optimize the topsides and target these key areas that we'd identified. We discussed these with the client, and through a screening process that we'd done with the client, we reduced these to 18 options that the client was interested in pursuing further. We then evaluated the technical feasibility of each of these options. So we modelled each of them again in Aspen HYSYS and subjected each to a capacity assessment. This was then able to tell us the impact that each modification had on the overall topside energy consumption, which directly then relates to CO2 emissions. We provided capex estimates for each of the modifications, estimated the OPEX savings that the operator would gain, and we also conducted a RAM model to identify the impact each option would have on the uptime of the plant. This was all then rounded into calculating the NPV short-term and long-term for each option. So here are the results from this project. Again, like the last one, when we were doing the capacity assessment, we actually identified that currently the topsides could be optimized at present with no requirement for capex. And here the gain would be to reduce their CO2 emissions today by 40 tonnes per day. This is something the client is already actively pursuing. They have already achieved a reduction of 20 tonnes per day, and this is something we're now working with this week to in fact get it to that target of 40 tonnes per day reduction. In terms of the capital project, we've defined a solution, well, the most favourable solution has an NPV of around 30 to 40 million over a 15-year period for a low investment capex of only 3.5 million. So short and sweet, but hopefully that provides a high-level insight into the type of projects that graduates are involved in at Atkins. And a thank you to my colleagues at Atkins for the support through my time and also for the nomination. Thanks to IChemE for the invitation to present today, and also thank you to everyone for their time. Happy to take any questions.
Okay, thank you, Karen. And once again, it is time for questions. So if you have got any, please type them into the questions box on the GoToWebinar portal. I'll give you a moment on that. And if you're enjoying this webinar, you may also be interested in the IChemE Young Researcher Award webinar. That's coming up on Thursday, the 19th of November. All of the IChemE Award webinars are free to attend and open to all. You can find out more at icheme.org/global awards. That's icheme.org/global awards. We don't appear to have any questions for Karen, so we'll move on. Thank you very much. Our next presenter, please welcome Kyriakos Hadjidimitriou.
Hello, my name is Kyriakos. I'm one of the IChemE finalists in the Young Industrialist section. And this presentation will outline my work that I have been doing with the National Nuclear Laboratory, the Centre for Innovating Nuclear Decommissioning, and the University of Manchester. And the title of this presentation is Waste Management and Process Optimization in Nuclear Decommissioning. Few things about me. I've got a bachelor's in chemical engineering and a master's in advanced chemical engineering. I'm a final year PhD candidate in chemical engineering at the University of Manchester, but based full-time in the nuclear industry. I'm also a chemical process engineer at the National Nuclear Laboratory, and I'm also a researcher at the Centre for Innovating Nuclear Decommissioning, which is a doctoral training that has full-time PhD students in the nuclear industry in the UK, focusing on decommissioning and waste management aspects. I'm also an associate member of IChemE, and I'm working towards my chartership as well. So the picture on the left-hand side, it's me working on a membrane technology ultrafiltration system, and my research interest focuses on the separation processes, membrane technology, modeling, energy efficiency, process optimization, nuclear decommissioning, and waste management. All these 6 interests, they have in common environment and process optimization that can be used in various industrial settings. So for the past 3.5 years, I have been working on the optimization of the membrane technology used by the Enhanced Actinide Removal Plant at the Sellafield site in the UK. So the Enhanced Actinide Removal Plant, or ERP, received active acid effluent generated from reprocessing plants and reactors. And through a chemical precipitation step, you form ferric floc and diluted in diluted solutions, and then you send that diluted solution in ultrafiltration system, a membrane technology system, where separation process is happening, and you collect the concentrated material and the solids on the interior part of the membrane, and then the contaminated fluid, which is the permeate, is being discharged to the sea. So the active material are sent for encapsulation through the encapsulation process and cementation. So our main focus and aim is to optimize the ultrafiltration system, but also predict the capability of the system if we alternate some of the parameters. So how we did that, which was part of my PhD as well, based in the nuclear industry. We first designed an ultrafiltration system using the same membranes as they used in active conditions, but this time in non-active conditions, so we can mimic the ERP operation. Also, we develop a model for the UF system that can predict the performance of the system and at different inlet conditions. And then we were able to validate the model through some experimental work, but also assess how the system will behave as we shift towards post-operational clean-out and we receive different process fluids into the system. We also tested different inlet conditions to actually see how the membrane will behave if we increase the pressure or if we increase the cross-flow velocity into the system. So by doing that and testing the model, we were able to actually have a very close proximity of how the ERP operates, and we verified this with the picture on the right-hand side, where we can see the on the y-axis the permeate generation against the feed, which is a performance parameter across time of how the process works and how the model we develop, how close it works with the plants. Some of the impacts of this research work were to be able to have the model being incorporated into the Sellafield Enhanced Actinide Removal Plant dynamic model, but also we did some complementary experimental work to support the National Nuclear Laboratories program. We also developed some collaboration and knowledge management between NNL, Sellafield, and the University of Manchester. Outside of my industrial work, I'm passionate about volunteering and supporting the next generation of scientists and engineers. I'm part of the STEM ambassadorship in the UK, but also I'm part of the NNL STEM group. We are also doing some outreach with the University of Manchester. From a leadership perspective, I'm the vice chair of the IChemE's Future Energy Leader Group, which we mainly focuses on aspects of the energy sector and how we can improve the current energy issues that we face as a society, but also how we can create a climate equity across the world. We also focus. I have also been a chemical engineering PhD representative on the European Congress for Chemical Engineers. Summary and next steps of my career, of my life as well. These are focuses on 4 sections: personal, professional, technical, and community. So personal involves in of course family and friends, but also continuous improvement of myself, becoming a better person. Professional, submitting my IChemE chartership soon, but also becoming a subject matter experts in these separation technologies, expanding knowledge in the nuclear decommissioning sector, but also supporting the next Center for Innovating Nuclear Decommissioning researchers joining the nuclear decommissioning industry in the UK, and continuing professional developments with IChemE and as a chemical engineer as well. Technical and PhD, hoping to submit my thesis soon, and from that PhD thesis will generate a couple of applications. I will continue supporting academic and industrial collaborations, as I really believe and I can see the industrial benefits when industry and academia are working together, and continuous involvement in R&D, as I'm passionate about research. And community, of course, I will continue be part of the various IChemE and chemical engineering groups, and also be a STEM ambassador. Acknowledgements. I'd like to thank, of course, from the University of Manchester, my academic supervisor, Dr. Tom Rogers, and Dr. Claudia Fonder. From the National Nuclear Laboratory, my industrial supervisor, Dr. Jay Dansford, and from the National Nuclear Laboratory and the Center for Innovating Nuclear Decommissioning, the management team, Professor Anthony Banford and Ed Butcher, and also the researchers that I have been working for the past 3.5 years. Thank you very much.
Okay, thank you once again. We have time for Q&A, so if you'd like to put any questions into the questions box, please do so. We'll just pause for a moment to see if there are any. Okay, it seems not, so we'll move on. Thank you, Kyriakos. We have 3 more finalists to go.
Thank you.
And next up is the winner of the IChemE Malaysia Young Industrialist Award. It's Mohammed Faiz bin Omar from the Malaysian Refining Company.
Hi, hello. Let me just get my screen out. Right. So I guess see my presentation.
Yes, we can, but we can see the presenter view. So if you want to just switch the settings so we can see the full slide view.
Display frame. How do I do that?
Yep, just where you were and just swap.
Swap.
Yep.
I can't click that.
Okay. I don't know if my colleague Charlotte will have any further tips.
Maybe if you switch your screens over, if you're using multiple screens.
I'm actually just using one screen.
Perfect. Yeah, that's
Okay.
fine.
Let me wait. Okay, just 1 second. All right. Okay, let me start. All right, so hello everyone. Good afternoon from Malaysia. So my name is Muhammad Faiz Umar, and I'm the finalist representing Petronas Malaysian Refining Company in Malaysia. So before I get on with my presentation, just a bit of an introduction about myself. So I'm Faiz, I'm 30 years old, and I'm currently the distillation technologist at Petronas Malaysia Refining Company, taking care of the sour crude distillation unit, processing roughly 107,000 barrels of sour crudes. Okay, so let's get started. All right, so I started my career journey when I graduated from the University of Melbourne in December of 2013. And so I came back to Malaysia in June of 2014 and started my career as a chemical engineer with Petronas in August of 2014 at Petronas Group Research and Technology. So this is the R&D arm of Petronas. Here I was involved with several R&D projects for Petronas, including mercury removal, CO2 removal, as well as the Petronas lubricant projects. I want to focus on one of my major achievement and contribution during my time here was in the development of Petronas's novel mercury removal technology, IChemE. Now, this is now an internationally commercialized mercury removal adsorbent, which is not only a greener and sustainable adsorbent, having used ionic liquids, but also has a faster kinetics, is more robust, and has a longer bed life, giving it the competitive edge both technically and commercially against its commercial adsorbent in this category. So my main contribution here in IChemE development was in the development of the engineering calculation engine and simulation model, which included the isotherm and kinetic model development, which improved the efficiency and fast-tracked the technology development by half its time, from inception up till commercialization. So through this contribution, coupled with more than 12 installations during my time, I managed to realize a value creation of more than $10 million for Petronas. And this technology also won the 2016 IChemE Malaysia Award for the oil and gas category. So that was my time during while I was in group research and technology. So from there, in May of 2017, I transferred to Petronas Group Technical Solution, which is the engineering and design arm of Petronas. So I was here for about 2 years, and I spent most of my time here performing and delivering several CAPEX and energy projects for Petronas, ranging from feasibility study up until detailed engineering studies and commissionings. My portfolio here ranged from gas business up to refinery, which included the Euro 5 project, the Kerosene refinery revamp project, several refinery unit upgrading and debottlenecking projects, as well as several energy and optimization projects within Petronas. Now, during my time here, one of the important projects that I led and was in line with Petronas's recent pledge of carbon neutrality by 2050 was the strategic energy review, which yielded an energy saving of a little over 20 megawatts, with annual benefit of $5 million for the refinery. In realizing the benefit, I performed a series of simulation and pitch analysis, which allowed for the significant energy reduction and improved the 3 EI points for the refinery, pushing it closer to its target of being a first quartile energy refinery. And I believe one of the major responsibilities of us as chemical engineers is to deliver solutions that are not only economically beneficial, but also sustainable and responsible towards the environment. And I believe this project is a living testament and demonstration of this pledge. And during my time in GTS, I was also seconded and was part of the commissioning team that delivered the successful pre-commissioning, commissioning, and startup of our new 300,000 barrel crude distillation unit at Pengerang Refinery. So this was the latest addition to our family, which is a joint venture refinery between Petronas and Saudi Aramco. So from there, so after gaining and contributing in R&D and engineering designs, in March of 2019, I moved to Petronas Malaysian Refining Company, where I'm assigned as the distillation technologist, taking care of the sour crude distillation unit. So this is my current position. Now, it has been my passion and dream to become a distillation specialist, and I believe this has been a first step towards the right direction in my career goal. And I think Steve Jobs said it beautifully when he said, people with passion can change the world, and this is exactly what I plan to do. To me, being able to do something that you love and is so passionate about, you go to great lengths to push your boundaries and to deliver excellence. So since March of 2019, I have led several unit troubleshooting and optimization initiatives that improve the refinery's energy efficiency and reduce greenhouse gases emission significantly. And initiatives included the zero flaring initiative, furnace operational optimization, as well as commissioning of the Euro 5 and several energy optimization projects. And during this recent COVID-19 pandemic and oil price slump, many oil and gas companies were significantly impacted, and Petronas was included. And I believe this tragic event not only impacted the society and nation, but also the economy. However, for me, this event also opened up the opportunity for us engineers to push our limits and boundaries to actually find better and more creative solutions to ensure sustainability during this sustainability. So I believe during this hard time, I also got the opportunity and led two major initiatives. The first one being the High Malaysian Crude Oil Processing Initiative, and second being the Kerosene Minimization Initiative. This High Malaysian Crude Oil Initiative essentially was about maximizing the unit's capability to process our Malaysian equity oil, which provided better margins and reduced the need to process the more expensive imported crudes. However, being a sour crude unit with maximum Malaysian crude oil processing capability of 30%, I managed to push the boundary of the unit, going beyond its initial design through running a series of process simulation and design evaluations and pushing it to the max. And by doing this, this enabled me to push the unit's capability to process up to 70% MCOs, which flipped the refinery margin at that time from being negative to positive and ensured sustainability of the refinery. And it prevented the need for a refinery shutdown that would have potentially impacted the organization, as well as the economy of the nation, the supply of energy to the nation. Now, this initiative also generated a year-to-date benefit of more than $6.3 million. Now, the second initiative I led was this Kerosene Minimization Initiative. Now, due to the declining demand of Jet A1 aviation fuel as a result of the pandemic and flights being grounded all over the world, I took the initiative and ran several simulations and unit validations and managed to reduce the kerosene production now through a series of creative engineering, which included internal column dumping, maximization of that, bypassing to our DHT system, as well as offsite optimization. And this in turn resulted in upgrading of approximately 300 to 400,000 barrels of per month of kerosene into diesel, and yielded a benefit of $12.1 million within the 3 to 4 months it's been running. And this initiative is continued running in order to ensure our sustainability. Now, besides contribution in terms of that, I believe as a chemical engineers, besides contributing towards the bottom line of the company and nation, ensuring sustainability and reducing carbon emissions towards carbon neutrality, and also reducing the impact of climate change. Another area that I believe is important is actually capability development and our contribution to the society and fraternity itself. So being able to have had a wonderful experience and career journey, I was able to develop these strong engineering skills, which enabled me to deliver excellent solutions. I also believe it is my responsibility to also develop other fellow engineers, and having that in mind, I initiated and developed this new process monitoring tool for MRCSV. So as you can see through the video here, which is actually my launching video that I created for the solution. Okay, this new tool accelerated the capability development of young engineers, especially the new ones joining the workforce. It reduced unit downtime due to upset and unwanted trips and ensured a smoother and more energy efficient operation. Now, unlike other tools available, this monitoring tool in essence combined the experience as well as the insight, which guides the engineer on understanding the unit, as well as providing direction and assistance in troubleshooting and ensuring the unit is optimized. So among the features that I built in were included notifications when certain products were off spec and one unit is failing or inefficiently operated, as well as provide early detection and prevention of unit trips. So all in all, this tool has been an important development in accelerating our engineers' capability to do the job well. And I believe it has been a great contribution, and we've seen significant improvement in our operation. And I, for one, find it really satisfying to be able to contribute on such a level and be able to make a positive impact towards this society as well as the fraternity. So overall, that is all from me and my sharing on my journey as a chemical engineer for 6 years. Thank you very much.
Okay, thank you very much. And once again, it's time for Q&A. If we have any questions, please share them in the questions box in the GoToWebinar portal. We'll just pause for a moment. Okay, we have no questions, so we'll move on, and we have 2 more finalists to go. And next up, it's Rhys Griffiths from PM Group. So over to you, Rhys.
Hi there, everyone. I hope you can hear me. Okay, can you see my screen there? Hopefully you can.
Yeah, that's
Yes.
all perfect. Thank you.
Okay, great. Thanks a lot. Yeah, so I'd like to say thanks to the IChemE for this opportunity to present a bit of my work that we've been doing over the sort of past couple of years. Just a bit about me. I graduated in 2017 from the University of Birmingham. Since then, joined PM Group's graduate scheme as a process engineer in the Birmingham office. So PM Group are a engineering design construction management company working primarily in the pharmaceutical and biopharmaceutical industry. So yeah, since joining the company, I've had a wide range of experience, both at the early design stage of new innovative facilities, as well as a couple of times on site doing the operational commissioning of equipment. So I actually joined a project in the first 3 months of my career over in Ireland, looking at a brand new biopharmaceutical manufacturing facility. And yeah, I'd never seen a bioreactor before, or had any real understanding of the industry or its specific needs. So that was a really good learning curve, and yeah, really set up a good foundation for my career. And so since sort of my time on site and in the office, I've also, in addition to my project work, been working on some technology initiatives. So I'm a member of the company's tech team. So yeah, so we do technology initiatives to benefit the industry, such as the standardized disposable design and the single-use design tool. So they're going to be the process, they're going to be the focus of my presentation today. So yeah, so hopefully I'll give you a good background to that. So yeah, first off, I want to talk about single-use design, single-use technology within biopharmaceutical manufacturing. So traditionally, equipment's sort of fixed equipment made of stainless steel, so it's a very traditional approach, and it's obviously well established, great for modeling and pressure and process control, and you get large scales up to 20,000 liters. But however, there is quite a lot of requirement there to obviously maintain the sterility between batches to avoid contamination. So need a lot of utilities for cleaning in place, steaming in place. A lot of energy goes into these processes for cleaning water and cleaning steam to make sure that you are assuring patient safety, really. And yeah, with stainless steel, you've got high capital costs, time for construction, and then once you've built the equipment, it's a lot of effort to move it, and you're left with a fairly inflexible plant, which is obviously good if you're just dedicating one production stream, but if you've got to do lots of others, yeah, it's a bit difficult. So that's where single-use technology comes in. It's made from lots of sort of plastic bags, plastic tubing. It's a lot of mobile equipment, so you can move it around a lot easier. It's faster to install. It's got lower capital costs then, and you can really improve your speed to market. So it's obviously great with getting getting patients with getting drugs to patients and therapies to patients quicker. There's no cleaning costs, none of the utility costs behind cleaning sort of water, purified water and steam. There are lower capacities, and there are sort of a lot of validation efforts to do with the type of plastic that you use. And obviously there's a lot of complexity added there because you're using a lot more, there's a lot more demand on the supply chain. Then that's the problems we're seeing. We're seeing a lot of our customers, they go for hybrid facilities, so they obviously still use the stainless steel approach, but with using single-use parts as well. Or we see, clients go fully single-use to these fully flexible facilities. And once you get to that point, you get a lot of bespoke assemblies and a lot of single-use design is done in development labs. And when that translates to manufacturing, it causes quite a lot of issues. You mean that, it means that the supply chains, there's a lot of demand on them. You see the warehousing costs and requirements going up, and with that goes the capital costs. There's often issues with security of supply. So often you'll single source to one specific vendor for single-use components and parts, and especially with the coronavirus pandemic, we're seeing that there are actually shortages of some materials and therefore single-use components, which then obviously those issues are then passed on to patients. There may be short supplies of drugs, which is obviously a major problem. And then because you have to revalidate these single-use components within a facility, it means that these problems can stay in place for the lifetime of a plant or process. So I think what we're trying to emphasize is if you get it right in the first place, then for the life of your plant, which might be over 20 years, you've got it right in the first place, and then you see the benefits there. So that's where standard disposable design comes in. So PM Group, we've established a range of standard assemblies, so looking at storage bags, filter sets, tubing, manifolds. And the aim is that with these standard designs, that we can get a network of suppliers to all offer the same design. So an end user can go to a company like Sartorius, or they can go to a company like Avantor, and they know that they're getting the same design. Obviously, there's validation costs required to get dual sourcing there, but they're under sort of common product codes. You know what you're getting. And then we're also looking to standardize within a facility, within a process. So, we're looking at tubing dimensions, bag capacities, connector types, to make sure that they don't sort of get out of hand and you're left with 20 different types of tubing dimensions. I mean, you wouldn't do it with pipe work. You'd stick to specific sizes with pipe work. So why would you do it with single-use tubing? And here is an example of one of the parts we have here. So we have a code for the internal and outer diameter of tubing. We have standard tubing lengths. We have a part code, so it's easy to recognize that this part is then a C139. So you know that it's C, so it's made from C-flex material, and it's 139. So that, we've given that assembly a name so that it becomes a shorthand within a site, so you know exactly what a C139 looks like. And you can go to Sartorius and ask for a C139. You can go to Avantor and ask for a C139, and you know that you're getting the same thing. And really the benefits are there. So, there's no design. There's really a reduction in design and qualification. So you can go to, they're almost off the shelf items. You can go to Sartorius and go to Avantor, and you can get a drawing returned very quickly. There's reduced work there to be done with the supplier for generating a drawing, getting a drawing approved. And then once you've reduced that time for design and qualification, you can get things to market a lot quicker, and you can establish that supply chain. A simplified and robust supply chain leads to reduced warehousing requirements and capital costs. If you're buying a lot of the standard designs on a larger scale, maybe in one facility, maybe in a number of facilities in different geographical locations, you're really looking at a reduced cost of goods and savings that can then be passed on to patients. Again, as I was saying, with a C139 assembly code, you can directly compare a cost between suppliers. You're getting the same design, so it's really a like-for-like comparison on cost. Obviously, there's other factors there. again, yeah, if you're using the same type of bags in different parts of the facility, you can train operators to use the same thing. They all get used to it. And again, inventory management, we're not seeing, you wouldn't be seeing sort of, run amok through SAP systems and things like that. You've got a reduced number of different components there. So this is something that we, believe in passionately at PM Group. And what we're trying to get over to our clients, get over to the industry, is that really the standardization and the use of we've got this arrow here saying use of SDD, but really that's thinking about standardization early, getting in at the concept to be the basic design stage, rather than thinking about it at detailed design when it's almost too late and you've got a lot more costs then. So that's where the single-use design tool comes in, and this is something that I've been working on personally. It was an internal initiative, but we've since successfully rolled it out to one of our clients, and they're using it for a fully single-use process. And it's all about visualizing a process early on, and once you've got everything laid out on paper, you can look and pick and say, okay, we need standard approaches over here and over here. We're using too many different types of tubing and too many different dimensions. So we believe it facilitates technology transfer from a process development lab to a manufacturing facility, or from one geographical location to another geographical location. As I said, it's a very visual process. You can pick it up quite easily. There's no language barrier there. And then also, once we laid out the facility in the single-use design tool, we can create an inventory of custom and standard assemblies. So you can look at getting a BOM list very easily, bill of materials list, sorry, very easily, and getting costs first thing, so you know how much your single use is going to cost you very early on in the design stage. And then, yeah, again, everyone likes working off diagrams. We do loads of P&IDs, but really, if you look at the single use, consumption throughout a process, you can learn and start training off that diagram rather than off P&IDs, which are really for, piping and equipment rather than single use components. So as I said, it's an in-house innovation for design of single-use processes, and I myself have been involved in rolling that out to one of our clients and getting them up and running with it, and getting the benefits in there. And this last point is quite key. So supplier drawings are often centered around their own production requirements. You often have to read a bill of materials alongside a drawing, and really it's not clear about what how that looks. Different suppliers draw things differently, and use different codes and different colors and things like that. So they're not really centered around the end user's needs. So that's what we're trying to get over to our. That's what we're trying to get over with the single-use design tool, is that once you go from this, which is a typical supplier drawing, and you have to read it in conjunction with the list to know how long these parts are and to know what exactly these are, and you've got lots of superfluous things like cable ties and things like that all clutter the drawing, to something that you can learn what an A code means in terms of internal, external tubing diameters. You can know the length of each piece of tubing. You've got symbols there, standard symbols for different types of connectors, and then you can factor in things like material, different materials, and really you'd sort of develop this standard approach across across your whole manufacturing facility, and people learn the shorthand, and they learn same way you would in a P&ID. You learn what each symbol means and things like that. So it really becomes part of the site language. And as I said, it's then looking at the logistics. It's quantifying the amount of single use there in terms of standard and custom assemblies. It's looking at how you streamline that strategy, so how you make decisions on tubing diameters. It's how you look at then housekeeping. When do you bring things to a production room? And really, it's really a great platform for training as well as logistical. So you can develop an inventory, and you can see all these different parts, how many we're using, and from then you export this to an Excel list and put in costs, and get a good value early on in the design process. And then you can look at, okay, do we need to focus on reducing the number of single-use parts? Can we get this particular, we're using this part quite a lot, is there another, is there a cheaper alternative, things like that. And you can add custom parts that go with the SDD parts. So really, if there is a really really bespoke assembly that you need, you can integrate that into the Visio tool, and you can also, use this as a design space, so you can sort of, thrash ideas out and see where things would go in a process. Okay, what if we did this and what if we did that? You can give them recognizable names, so you're not referring to custom assemblies as like a thingamajig or something like that. You can give it a name, and that will show up in the inventory, and it will show up in the diagram, so you can say, okay, this goes here and that goes there. So and then kitting and sub-kitting, I've explained this. It's sort of looking at when to bring things to the floor, when to can you create different inventories for different kits and sub-kits. So really looking at streamlining the approach to manufacturing. So for example, if these are the total kitting requirements for your fermentation batch, maybe everything in red you need at the first day of fermentation, maybe everything in blue you need later on at day 10. So it's really looking at when do you need things on the factory floor, rather than, hard to read that off under engineering drawings. Again, where do things go when connecting to equipment? Are there different steps in which you use the same nozzle but different single-use components? So it's all about providing clarity to operators and engineers working on site, and you can use this to train operators. Everyone likes working on something visual rather than a set of written instructions. And again, if you're transferring one site to another site, one process to another site, it's a visual tool, so you can get everyone up to speed quickly. And if you want to have a change in single-use philosophy or changes to a process, they can be easily communicated by marking up a drawing rather than lost through translation, lost through written words. Sorry, I appreciate I rattled through the the last part of that pretty quickly, but I noticed I was sort of overshooting on time there. But yeah, I want to say thanks to everyone for listening first and foremost. But yeah, thanks to the IChemE for the opportunity to share what I've been doing. And yeah, thanks to my colleagues at PM Group, especially Javier Lozano, Dave Walton, who's not at PM Group anymore, but yeah, they've been really great in mentoring me with the single-use side of things. So yeah, thank you very much for listening. Happy to take any questions.
Okay, thank you. We have a question. As part of the development work, have you been able to assess the life cycle impacts of using disposable design versus the conventional approach in terms of both the decreased supply chain holdup and wastage compared to the older custom assembly single-use approach, and increased use of resources and embedded energy in the single-use products versus the energy of water use for CIP/SIP activities?
Yeah, there is a lot to unpack, obviously, with life cycle analysis of single-use parts. What we are doing is we are preparing a white paper to look at, as I said, a standardized approach versus a non-standard approach or a stainless steel approach. So we are working on a white paper to hopefully explain some of those benefits, again, from a cost point of view around the warehousing. Yeah, in terms of life cycle analysis, it's quite a lot to unpack. I know there is some stuff out there. Obviously, a lot of energy goes into producing purified water, purified steam. So yeah, it depends on like the geographical location of where sites are placed. There may be some places where traditional stainless steel is maybe better than the single use because it's got a cleaner energy mix and things like that. But yeah, as I said, it's quite a minefield when you get into it, and it's something that I think definitely the industry needs to look at. But there are benefits other than sort of the cost and environmental benefits that we see from single use. Particularly around flexibility. We're seeing quite a lot of facilities come through where they're maybe for clinical trial supplies or they're for development processes where they need the single use there for flexibility. You can make multiple products, or you can make one product that's just going to clinical trials, but it may not reach it. So you may want to reconfigure your your process and your facility. So yeah, I appreciate the question. I think it is something definitely to consider. And as I said, we are working on this this white paper that will hopefully shed some information on that. But yeah, it's obviously a massive talking point.
Okay, thank you. We need to move on, so thank you very much, Rhys.
Yep, thank you.
We'll now move on to our final speaker. It's To Ji Hao from Croda, Singapore.
Hi, good evening, everybody.
Before we start, Tao, if you just want to switch your display settings too, so we can see just the slides.
Right. Is that all right?
If you go up to the top where it says display settings and swap presenter view and slide view, that's perfect. Thank you.
All right. Right. So it's 7:30 p.m. here in Singapore. I'm To Ji Hao, representing Croda Singapore. So today I'm going to bring you on a journey. First off, with introducing the character myself. My name is To Ji Hao, also known as Bear, because I used to be really huge and weighing in about 140 kg. I'm 30 years old this year and I'm from Singapore. So the iconic of Singapore, it's the Merlion you can see in the image and Gardens by the Bay. So I live by a motto to be a history maker and make things better than the norms. So I live by that and implementing that into my daily life and in my career as well. So about me, I was always first in class since primary school, counting from the back. So if you didn't get that, it means I wasn't a very bright student. I'm commonly labeled as stupid, idiots, or born to be a toilet cleaner. And then I end up myself in the Institute Technical of Education. So braving through all these waves, I managed to finish my university finally. I graduated with a Bachelor of Engineering in Chemical Engineering with honors, with a second upper class. It's a joint collaboration with Singapore Institute of Technology and Newcastle University based in UK. During my education journey, I always remember what my prof have shared with us, during the first day of school is we are not here to mark your final answer, and we are here to look at the process to getting the answer. So what's at the end, it's really not important, but the learning process in between. So after graduating from uni, my very first job was with Croda. It was an intense interview with over 100 candidates from top-notch university. I was the lucky two of the final candidate that got the trainee program sheet. So it was a 2-year program. I was rotated into the research and development department, production, supply chain, and engineering. And then after my graduate trainee, I was posted into process engineer for a year, and then I shifted to being a project engineer. And right now, within a short period of time, I accomplished to become my assistant plant manager for the finished goods and building. So one of the proudest moments as a graduate trainee, with putting all my engineering skill into it, was the blue production. So a little bit background of what a blue production is basically a production where it's a co-process. So we do all the chemical mixings without the use of any heat required. So it has a long history of about 10 years. It used to be a 4-day production. And then when I was rotated into this blue production, I managed to cut it down into a 1-day production. So what have I done? Well, I'm always a strong believer in doing the job using my own hands to know what's going in from the start to the end. So I went down for months to follow the technicians on how they do this production. And then I gather the feedbacks and finally make the changes. It wasn't a smooth process, so but I'm glad I finally made it. So some of the changes was to just have a better storage management so that the raw material, when it comes, is at a exact spot where the production is happening. And then this production requires charging in a powder substance. So conventional method, they were all using vacuums. So I took the convention out and did some risk assessment and hazard analysis, to allow the scooping and pouring method, which saves a lot of time. And then, of course, with the reduce of workload required, managed to cut down the man hours from 2 to 1. So right here, what I was trying to do is to increase the efficiency and creating value through innovation. So after all the rotation, my first big challenge after I graduate as a process engineer was to take on the automation. I had to do the costing, the planning, the design work, and the site work. So during this process, I had learned some stuff. I had to unlearn and relearn. Okay, so it is a first step for Croda Singapore to step into the automation world. We had no experience. We have no ground experts to guide us through. We had to source for contractor to tear down and build up the line of automation. We are basically a blank page, and we didn't know where to start and who to look for help. So in the end, we did some research online articles, reading some of the reference from various experts. I'm finally great to say that we managed to commission our automation line. I really wish that I can showcase the video that I made in-house to show to my senior management. If you could just take a picture of the link, and after this whole presentation, maybe you can log on to YouTube and take a look at this wonderful automation that we have put in place, right? So doing automation, definitely, in school, we are always taught, there's always pros and cons. But however, for Croda Singapore, it's more of a pros than cons. So conventional method, when the finished goods come over, it requires my operators to be inside the booth, packing it, weighing it, and then sewing it, and then laying the bag down and sending it out through the conveyor belt, and then picking up and stacking and palletizing and whatnot. So it's lots of ergonomic issues. I have operators coming to the manager saying, I'm having backache today, I'm not coming in for work, and lots of fatigue issue. So with automation, obviously we automate the whole thing from the bag fillings to the weighing, to double weighing it, to labeling, to using the robot arm to stack the products, everything. We provide training to our current operators. We upgrade their skills and make sure that we provide them with a different type of working experience with Croda Singapore. As we also had overseas support from Malaysia, especially during this COVID period, when we have bugs happening in the automation, just with a phone call and a laptop plug into the system, they are able to support us 100 miles away from Singapore, all the way from Malaysia to help us debug some of the problems that we have. And definitely with data record supporting, we are getting more outputs than before. So as a chemical engineer, we don't just confine within our own bubble. Especially myself, I always love to give a helping hand to the other departments, improving the systems and growing as a company, as Croda, as one. One of the things that I took initiative was to help out with the behavioral-based safety. It used to be a paper and pen, so the assessor will have to go on site with a paper and a pen and then do the assessment, and then they will pass it back to the safety officer, and then our safety officer have to key in all the data into the computer, tabulating it and running all the different results and showcasing it to the senior management. However, I have bring it all online to a platform. It's a joint collaboration with iAuditor. So this platform allows my auditor, the assessor, to go on site with a tablet, doing the assessment, and then sending it online. And through the online platform, the data all can be put in different ways and however you want to analyze certain things and behavior of the site. So in this, I have both achieved the sustainable of cutting the paper and pen and bring it digitalized using tablet. So I didn't just stop there. I went on to help with the safety department on a very interesting project, location tracking. So I'm sure all of you, during a fire alarm, all of you had to exit the company compound, and then you have a safety marshal there taking attendance, shouting your names here and there. So I found a specialized programmer on the Singapore side, and I had a collaboration with them on getting them to do this contact tracing for Product Singapore. So what this does is actually the pass in every employee comes with a Bluetooth chip. So this Bluetooth chip will then identify where each employee will be at the live timing. So during emergency, when everybody is needed to evacuate the building, through a tablet that is placed right outside the gate, whoever that passed by the tablet will auto detect that the person has left the company compound, and whoever that is trapped inside will be crossed as red. So we have to refer to another tablet to see where is that last staff trapped or stuck. So in this situation, during a rescue time, you certainly save a lot of time going around the company boundary to look for that specific person, where in the look of a tablet, you can see where the person is last location. So Product Singapore is on a continuous improvement. Our journey continues with a lot more digitalization coming out, such as personal advancement. We have a virtual reality for training, where our staff will put on a VR with some earpiece and handset, where they will perform some of the tasks such as opening a palm, doing a process line up, and then there will be a test assessment throughout the whole system. And process advancement, we are going to have a real-time control chart monitoring. We are going to bring our process batch recipe online as well. We are also going to go on board with the dashboard data analytics with Aspen to help us optimize our processes. So today's winner, I don't know who, but I'm just one slide away from releasing, as in the IChemE will release who the winner is. But no matter the case, congratulations to all the finalists. Everyone is a winner. We are all best in our own special ways. I've definitely learned a lot from the other finalists that I've shared earlier on. And thank you all for your attention. I'll take this time to thank my site director, Mr. Chan, for the nomination. My UK marketing, Ms. Jennifer, for the heavy publicity on my entry into IChemE, and all the colleagues and management for the support. And thank you, IChemE, for organizing this wonderful sharing session. Thank you. I'll be glad to take any questions.
Okay, thank you very much. So for the final time, we have a moment for questions. So we'll just pause, and if you have any questions, please type them into the questions box on the GoToWebinar portal. Right then, there are no questions. So just to echo what Toad just said, I'd like to extend a big thank you to all of the finalists for sharing their work with us today and being with us today. We have got 8 outstanding candidates, but there can only be one winner. And I have the pleasure of announcing who it is. First, we have our 2 highly commended entries, and they are Joshua Kelly and Mohammed Faiz bin Omar. So well done and congratulations to both of you on achieving highly commended status. But now for the winner. So ladies and gentlemen, the winner of the IChemE 2020 Young Industrialist Award, sponsored by the chemical engineer, is Heather Williams. So Heather, congratulations. Hopefully we can get you back on the line now, back on camera perhaps. How does it feel to be IChemE's Young Industrialist of the Year?
I am very shocked, is the honest answer. After listening through all the presentations, I genuinely didn't think I had a chance. Everybody else is incredible. They all do amazing things and really, really are credit to the society. It's great. Yeah, slightly shocked, but thank you.
Well, is there anyone you'd like to thank before we wrap up?
Absolutely. I mean, all my colleagues at WSP have been immensely supportive and have really helped forward my career. And also all my colleagues at the IChemE, looking at the National Young Member Committee and everybody else that supported me and supported that group. And yeah, it's a real honour. Thank you.
Well, thank you. Congratulations again, and well done to all of our finalists. Thank you for being with us today. That's all for this morning. As we said, there's plenty more to come in terms of our awards webinars, so do head over to our website if you want to register for any of the other sessions we've got coming up this month. But for now, it's congratulations to Heather and good morning.